we'll go with the next concept in inverse Laplace transform. Here we are going to see the inverse transform of logarithmic functions and inverse functions. If the question is in terms of logarithmic function or inverse function, what do I mean by inverse is sine inverse, cos inverse, tan inverse, such questions when they come, or logarithmic functions means log of when they come. And if we have to find for inverse transform, that time we are going to adopt for this method. So to start with, to adopt for this method, you should have known with the property which you have seen in Laplace transform. Which is that property is multiplication property, or it was said to be what? Derivative of transform property. What it was given? It was stated as Laplace transform of t raised to n f of t is equals to minus 1 raised to n d raised to n by ds raised to n of f of s. This was the multiplication property stated in Laplace transform. Now if I substitute n as 1 in this statement, it will become Laplace transform of t into f of t is equals to minus d by ds of f of s. D by ds means what? It is derivative, that is first derivative of which function? F of s. So this notation can be represented as f dash of s. This is Laplace transform of t into f of t will be equivalent to minus f dash of s. If this L operator comes this side, it will become L inverse of minus f dash of s, which is the answer as t into f of t. This concept we are going to make use in problems. Means L inverse of minus f dash of s will be substituted as what? T into f of t. Similarly, if you take n equals to 2 in this, so it will become Laplace transform of t square f of t is equals to minus 1d square will become plus d square by ds square of f of s, and d square by ds square of f of s is f double dash of s. Taking this L operator this side, it will become L inverse of f double dash of s, which is equals to t square into f of t. So in the problems when you go with the L inverse of f double dash of s, that time I will be substituting it as t square into f of t. So with this concept, we are going to see the working procedure for problems. Now what exactly we are going to do in such problems is, when the given function is a logarithmic function, okay, so question is having log of something, that time very first step we are going to apply for logarithmic properties. What do I mean by logarithmic properties? I am going to apply log of a by b property, which can be written as log a minus log b, or it might be log of, that is a raised to m, can be written as m log a. Such two properties I am going to make use in this. Even the product property I will be using, that is log ab is equals to log a plus log b. So when I apply for that property, the very next step is I am going to differentiate the function. Here the given function, logarithmic function, is always denoted as f of s. That f of s is equals to log of something will be differentiated with respect to what? S. From that I will get what? F dash of s. Once we get f dash of s, we are going to multiply both sides by minus 1. After multiplying minus 1, I'll simplify the terms and then take inverse Laplace transform on both sides. Once we take an inverse operator, we will get t into f of t, or t into f of t, and this t will be shifted to the denominator of the other side. From that we'll obtain what? F of t. That will be the solution for the given function. Suppose now, after differentiating, if the function is again having log function, this procedure should continue, that is differentiation should continue till log function goes. Okay, so if log function remains once you differentiate, that is in f dash of s, if answer comes in terms of log, then again we have to differentiate it with respect to s, which will give you f double dash of s. That should continue till log function goes. So here once we get f double dash of s, you should not multiply minus sign now. Directly you have to take L inverse on both sides. If you take L inverse on both sides, you will get the answer t square of f of t equals to. And that t square, when it comes under the denominator of the other side, you will get your f of t as the solution. This is when the log function is being given. In case if inverse function is given, what we do? We directly go write for f of s, then we differentiate it with respect to s, then take L inverse on both sides. Okay, so this is the procedure to solve for the logarithmic functions or inverse function. In the next video, we will see the problems on it. Thank you.